One day, a woman named Carrie decided to have a little taste of the sun. She doesn't get to spend as much time outdoors as she would like. Between work at the office and busy evenings at home, getting back to the nature is rarity. Today, however, she's going to change that. She's lounging in the sun at her favorite beachside resort, armed with a bar tab and trashy novel. Unless she wants her day to end in a painful sunburn, Carrie knows she'd better lather on the sunscreen too.
The ozone layer. As we all know, its the main function is to provide a barrier to ultraviolet radiation by filtering out these rays from the sunlight. The ozone layer lies approximately 15 to 40 kilometers or 10 to 25 miles above the Earth's surface in the stratosphere. Stratosphere, a mass of protective gases clinging to our planet. It is the region out of the atmosphere above the troposphere. It extends from about 10 kilometers to about 50 kilometers in altitude. The ozone layer is the common term for the high concentration of ozone that is found in the stratosphere. Ozone is a gas that exists naturally in our environment. Each ozone molecule contains 3 atoms of oxygen and is denoted chemically as O3. It is found primarily in 2 regions of atmosphere, about 10% of atmospheric ozone in the troposphere. Troposphere, the region of the atmosphere closest to the Earth. The troposphere extends from the surface up to about 10 kilometers in altitude. The remaining ozone, about 90%, resides in the stratosphere between the top of the troposphere and about 50 kilometers or 31 miles in altitude. Formation of a stratospheric ozone. Stratospheric ozone is formed naturally by chemical reaction involving solar ultraviolet radiations, which is sunlight, and oxygen molecules, which make up to 21% of the atmosphere. In the first step, the solar ultraviolet radiation breaks apart one oxygen molecule, which is O2, to produce 2 oxygen atoms. In the second step, each of these highly reactive atoms combines with the oxygen molecule to produce an ozone molecule, which is O3. This reaction occurs continually whenever solar ultraviolet radiation is present in the stratosphere. As a result, the largest ozone production occurs in the tropical stratosphere.
Ozone can be good or bad depending on where it is present. Because of its protective nature, stratospheric ozone is commonly referred to as good ozone. It acts as invincible shield and protects us from harmful ultraviolet radiation from the sun. In particular, the stratospheric ozone protects us from the UV radiation known as UVB, a band of ultraviolet radiation which wavelengths from 280 to 320 nanometers produced by the sun. UVB is a kind of ultraviolet light from the sun and sun lamps that has several harmful effects. UVB is particularly effective at damaging DNA, melanoma, and other types of skin cancer are caused by it. Long-term exposure to high levels of UVB threatens human health and damages most animals, plants, and microbes. On the other hand, because it's occurring near where we live, where we can breathe it, ground-level ozone or tropospheric ozone is commonly referred to as bad ozone. Though it also absorbs ultraviolet radiation, inhaling it can trigger a variety of health problems, including chest pain, coughing, throat irritation, and congestion. It can also worsen bronchitis, emphysema, and asthma. It can also reduce lung function and inflame the lining of the lungs. Repeated exposure may permanently scar the lung tissue. Ozone layer depletion is the thinning of the ozone layer present in the stratosphere. This happens when the chlorine and bromine atoms in the atmosphere comes in contact with the ozone and destroy the ozone molecules. One chlorine can destroy 100,000 molecules of ozone. Some compounds release chlorine and bromine on exposure to high ultraviolet light, which then contributes to the ozone layer depletion. Such compounds are known as ozone depleting substance or ODS. The ozone depleting substance that contain chlorine, including chlorofluorocarbons, carbon tetrafluoride, hydrochlorofluorocarbons, and methyl chloroform, whereas the ozone depleting substance that contain bromine are halons, methyl bromine, and hydrobromine. Bromofluorocarbons, CFS, are the main cause of ozone depletion. These are released by solvents, spray, aerosols, refrigerators, air conditioners, etc.
Violation of the ozone layer is a serious issue, and the various programs have been launched by the government of various countries to prevent it. However, steps should be taken at the individual level as well to prevent the depletion of the ozone layer. The following are some points that will help in preventing this problem at a global level. Number 1 is avoid using ODS. And number 2 is minimize the use of vehicles. And number 3 is use eco-cleaning products or eco-friendly cleaning products. And last but not the least, use of the nitrous oxide should be prohibited.
The formation of stratospheric ozone, like sunscreen, protects humans from the sun's harmful ultraviolet rays. The major difference is that when we don't apply sunscreen, the damaging ultraviolet radiation only affects us. Whereas, if stratospheric ozone isn't formed, it has a major impact on the entire planet. Not just people, as a result, we will be faced with a massive challenge.